Okay, we're going to optimize perimeter. Similar to what we just did with optimizing area, but in this question they've actually given us the area of some object, and again it's a four-sided shape. And when we optimize perimeter, we're actually not finding the max perimeter, we're trying to find the minimum. The smallest amount of material we'll have to use, it's supposed to be an N, smallest amount of material we'll have to use in order to enclose an area that's 100 meters square.
Sir,
right?
So you use optimizing for max?
So, what we're going to do is we're going to look at different perimeters. Same idea, we're going to set up a chart. Okay. Now we know our area is equal to our base times height. So we're going to come up with different base lengths and height lengths, and we're going to solve what the perimeter will be when we have these values. Okay. So again, we set up this chart that we did before. The first thing we're going to work with, we'll call it the base or the width, whatever you like. Then we'll have a height. The area should always be the same. What will it be? 100 meters squared. And we're going to be looking for perimeters. Okay, so again, we're going to plug in values for our base. Again, we're going to try to work with whole numbers as we plug in. I'm not too concerned with the decimals yet. Once we work through it, we may find something later on. We'll work with whole numbers to start. So let's say we had a base of 1 meter. What would the height of this object have to be in order to get that area? It'll have to be 100, right? Because remember, the operation we use here is multiplication to find our area. So we'll need a height of 100, which means we're going to have 2 sections that will be a meter and 2 sections that will be 100 meters. What will the perimeter of this object be without me writing down a formula yet? 202. Remember, the perimeter is where we add all 4 sides together, or you can think of it like this: 2, because it's a 4-sided shape, times L plus W. So if we add our L and W, or our base and height, that's 101 times the value of 2. We're going to have a perimeter of 202 meters. That's pretty large, okay? You don't want to work with something that's too much material to enclose such an area. So let's go up. 2 meters. What can I multiply to get our 100 meters? That's right, 50 meters. Now again, we're going to have 2 2-meter bases and 2 50-meter bases. What will that give us as a perimeter? Not 102. 104. We add these together. 52 times 2. Use your calculators when you go through this. 104. Okay, so already that's reduced a lot of material. Okay, so that's a much nicer one to work with. Let's go up again to 3. Now, this is a little more difficult. 3. How can we find out 3 times what equals 100? What process could we use?
33.3.
How did you do that?
It's like infinity. Because you can't like really get.
Okay, what operation could you have done to figure out this height? That's right. If we take that 100 and divide it by 3, we could figure out what our height would have been. And you're right, it's going to be 33.3 repeated. Okay? So, say we added those together, we'd have 36 times 2. What are we going to get as a perimeter? Anyone know? What is it? 72.6. Yes, that's right. Whoops. 72.6. Oh, that did. There you go. 72.6. Okay. So now that we know how to solve height, even when we have values that aren't whole numbers, we're going to go through this process a little quicker. I don't know what it's doing this. There you go. 4 meters. 25. Excellent. Which means what are we going to get overall as a perimeter? 58. That's right. Try to follow along with those calculators. We added those together, multiplied by 2. Next value. 5 times what equals 100? 20. Which means we're going to have what as a perimeter? 50. Good. 50 meters. Now, 6, 7, 8, and 9, we're going to be working with decimal numbers. Okay? Our perimeter is going to be difficult to figure out. I want to jump right to the value of 10. 10 times what value? That's right. 10 by 10. Still, we're going to get an area of 100 meters. What will our perimeter be in this case? 40. Good. Now, just to verify, you're right, because if we have 4 sides of 10, okay, just to verify, I want you guys to solve for 9 and 11. Just to make sure, because what you guys, we didn't quite talk about in the last one, is there should be a pattern as we go through this. The perimeter should keep dropping to a point, and then after that point, it'll pick up again and never come back. Okay? So we're going to specifically solve for when the base is 9 and the base is 11, just to make sure it is larger than 10. I went on a guesstimate and guessed that a square would be best. So, let's go down. 9 times what is going to give us 100? Who can help me out with that? Is that what it is? 11.1. There it is. So that, what will our perimeter be in that case, Sam? Add those together. What is it? 44.4. No, it should be 40.2.
Wow.
40.2. Good. That is larger than our 40, right? We're trying to minimize that perimeter. So that amount was larger, so 40 was probably a good guess. And let's see what 11. 11 times what gives us 100? 11 times, not 9 exactly, but...
9.09.
Is it 9.09, Sam? Yeah. We could, and let's check with our calculator just in case. Why isn't this clicking? Here we go. 100 divide 11, and this is how 100 divided by 11 equals 9.09. Excellent. Add those two values together and multiply by 2. What are we going to get as a perimeter? 40.82? 1.8. Okay, roughly 40.2 again. So, it turns out, what shape did we make with 10 and 10? Square. And we had already learned that in the last one, right? That our square is going to give us an optimal shape when we're finding perimeter and area. So in this one, they gave us the area, and we need to find a minimal value. So minimum fencing. Think of it like we're buying fencing. I don't want to buy 202 meters of fencing. That's going to cost me a lot of money if I can enclose 100 with just 40 meters of fencing. Okay?